Welcome to our lesson on measures of spread. I'm going to talk to you about the different measures of spread like range, standard deviation, interquartile range, and the 5-number summary. These examples are going to help you understand how to describe the variability in the data sets, whether it represents a sample or a population. So first, let's take a look at the definition for measures of spread. Measures of spread describe how much the data values vary or spread out from the center or the mean of a data set. This helps us understand the consistency or variability in the data. So, just like a measure of center told us about what the typical value is in the data set, measures of spread is a number that represents how spread out the data values are. So these are the different ways that we can measure spread that we're going to talk about in this class. We have range, and that's the difference between the largest and the smallest values. We have the interquartile range, which we already talked about that, but now we're going to talk about it in terms of measures of spread. And this is the range of the middle 50% of the data. That was your Q3 minus your Q1. The variance is the average of the square deviations from the mean. So whatever your standard deviation is that we're going to talk about next, that's going to be the standard deviation squared. And the standard deviation is the average distance of data values from the center or from the mean. These measures help us determine how tightly or loosely the data points cluster around the center. That is a great way to explain what we're talking about here. Now, there is a formula for the standard deviation, and it's different depending on if you're talking about the population standard deviation or the sample standard deviation. Just as a quick refresher, the population is everybody in the group that you want to study. And a sample is when you're just looking at a subset of the population. We usually use samples because typically we don't have access to everybody in the population. So then we take a smaller group that represents the entire population. So depending on if we're calculating the standard deviation from all of the data values in the entire population, then we would use this formula here. If we are calculating the standard deviation based on just the list of the sample data values, then we would use this formula. Notice the only difference is the denominator under the square root. The capital N is the population size, meaning instead of talking about the sample size, how many values are in the sample, that's our lowercase n here. And when we talk about the population size, we label that as capital N. Now, I'm going to show you how to calculate these values on GeoGebra because although these calculations aren't hard, it can be pretty tedious, especially if you have a large data set. Something else I wanted to point out to you is that when we're dealing with values that summarize the population, remember those are called parameters. And it's important to distinguish the difference between parameters or statistics when we're looking at numbers that summarize the sample. The symbol for the population standard deviation is lowercase sigma. That's this, it looks like a circle with a little baseball cap on top. That's lowercase sigma, and that means the population standard deviation. When we're talking about the standard deviation, but it's coming from the sample, or it's calculated based on the sample, then we use just a lowercase s. Sometimes you might see it also like this with an S with a little X below it, like a subscript. But these are the different notations to indicate whether or not the standard deviation is coming from the population or if it's coming from the sample. So since we're reviewing parameters and statistics, I created a chart here that summarizes the different symbols so far of what we talked about. So when we're talking about a mean, but it's calculated based on the entire population, then we use this Greek letter here. It's pronounced, I'll put it over here, it's pronounced mu. So that represents the mean of the population, and because it's coming from a population, it's considered a parameter. When we're talking about a mean that's coming from the sample, we use the X bar symbol. And because that mean, if it's coming from a sample, that's considered a statistic. Now, when we're talking about the population standard deviation, this is what we just talked about. That symbol is lowercase sigma. And when we're talking about the sample standard deviation, that's S, or you might see it as SX. But that would be a statistic because it's calculated based on the sample. And then again, a quick review. When we're looking at population size, we call that capital N, and lowercase n stands for the sample size. So to recap this important information before we move on to the examples, we know that standard deviation tells us how spread out the data is from the mean. There are different formulas and different symbols for the populations and the samples. And the symbols we use depend on whether we're describing a population or a sample. So that is very important. Now, if you ever forget what symbol means what, you have it in your notes so that you can come back and look it up. Let's look at example 1, and we're going to look at 2 different data sets and make some calculations. Now, some of the information that we need to make these calculations, we can use GeoGebra to help us find. So first, for step 1, let's find the one variable statistics for each data set. So let's hop on over to GeoGebra. So when you enter GeoGebra, put your data set values in each column for A and B. And we're going to use the one variable statistics or one variable analysis to find all the information we need to answer all these parts of this question. So pause the video, make sure you get your data values in there. And then once you're ready, unpause and I'll walk you through the steps. For data set A, I'm going to highlight the data values, click on the histogram item, and choose one variable analysis. Then I'm going to come over and choose the Sigma X button that shows the statistic values. So for data set 1 in column A, here's all the information that we need listed out. I'm going to copy it down. You should do the same. Then we're going to do the same thing and find all the values we need for data set B. So I'm going to highlight data set B, click on the histogram icon, and choose one variable analysis. And then come over here and click the button to show our statistics. And here's everything written out that we need for data set B. So take a minute and copy that down as well, and then we'll hop back and work through all the parts of this question. Okay, so I listed out all the information for each data set. I put data set A information in green and data set B information in red. And I rounded everything to 2 places. So let's look at part A. To answer part A, we need to find the range for each data set. Now, just a quick refresher, the range is the maximum value minus the minimum value. So when I look at data set A, the maximum value is 55 and the minimum value is 45. So the range of the entire data set is equal to 10. For data set B, the maximum is 7. The minimum is 1. So the range of the entire data set B is going to be 6. So that tells us how spread out the data values are from the min to the max. For part B, we have the sample standard deviation. Now, it's very important to pay attention to the differences. If you notice at the beginning of the question, it says we're given a sample of data sets. So each of these data sets represents a sample. So when we're asked to find the standard deviation, we want to make sure that we're looking at the sample standard deviation. Now, the sample standard deviation for set A, that is 3.5. Remember, sigma, lowercase sigma, represents the population standard deviation. So we don't want to use that value. We want to use the sample standard deviation, which for set A is 3.5. Now, for data set B, if we look at the sample standard deviation, we have 1.93. Now, I didn't have this written in the example, but if we're looking for the variance, then you take whatever the standard deviation is and you square that. That will give you your variance. For part C, we're going to find the interquartile range, which if you recall from one of the previous lessons, that is our Q3, which is our upper quartile, minus our lower quartile, Q1. So for data set A, my Q1 is 48, and my Q3 is 53.5. So I'm going to take 53.5 and subtract 48. That's going to give me 5.5 for my interquartile range. Now remember what that means. That is the distance of the middle 50%. Or if you're looking at it visually, when you're looking at your box plot, it's the length of the box from Q3 to Q1. It's the range of your middle 50%. Okay, looking at data set B, if we want to find the IQR, I need to take my Q3, which is 5, and subtract my Q1, which is 2, and that gives me an interquartile range of 3. Looking at example 2, we have ice cream consumption. The following data represents the complete set of daily ice cream consumption in gallons for every household in a particular neighborhood. Notice how this says every household in a particular neighborhood. So, since we're focused on this particular neighborhood and we have the data for every single household, this data set here is not considered a sample, it's considered a population. So that means when we go to find the mean, we want to make sure that we write our symbol with mu. And we also want to make sure when we find our standard deviation that we're finding sigma, not S, because we need to calculate this based on the fact that this is an entire population. So I put my data set for this example in column C. So to find my mean and my standard deviation, I'm going to highlight the data. I'm going to choose click on the histogram icon and choose one variable analysis. And then I'm going to choose the statistics button, show statistics. And then that will give me my information here. So my mean for this data set is 4.4. Just a quick refresher what that means. That means we add up all the values and we divide by the total number of data values. So if we look at the sum of all the x's, that's this value here, that's 44, and we divide by the sample size, or the population size, I should say, is 10, that's where the 4.4 is coming from. That's the mean. Now, when we're looking for the standard deviation, because we know that this is a population and not a sample, we want to make sure that we are looking at the lowercase sigma symbol. This here, the 1.1619, that is our population standard deviation. So for part A, our answer is going to be mu equals, because it's the population mean, and we're going to write 4.4. And for the standard deviation, because we're looking for the population standard deviation, we're going to choose sigma, and that was 1.16 when we round it to two places.